You may already be aware of how nuclear weapons can endanger everything in their path. However, did you know that it can happen on land, underwater, and even in space? It's worth noting that the effects of explosions in these various locations vary. The effects of nuclear bombs when dropped on Earth might be somehow clear to you now, but no one knows what will happen if they are launched in space. Do you have any idea what would happen if nuclear bombs went off in space? Not one, but several of them. Isn't it both interesting and terrifying? For today's video, we will go into that. So let's not waste time and let's get this started. Well, to start this, it's important to mention that there are many people, aside from me, that have conducted this study. In fact, there are several similar studies about this that have been carried out. One of these was Operation Argus. This operation happened in August in September 1958, in which a series of US nuclear weapons were detonated at various altitudes over the Atlantic Ocean. To be exact, 3 nuclear warheads were released in this operation in space. The first 2 warheads were launched at around 170 kilometers. That's 105.6 miles and 310 kilometers, or 192.6 miles above the Earth's atmosphere, while the third warhead went off at a height of 794 kilometers, or 493 miles. However, there is no serious damage since the released shells were too weak. Moreover, the explosive power of all 3 W-25 nuclear warheads is only 1.5 kilotons each. There is also an operation called Starfish Prime in addition to Argus. A number of explosives were launched in space during this operation. The aim of this operation is for scientists to know what could happen if nuclear weapons were launched in space. However, scientists have also discovered the effects of such an explosion on Earth. On June 20, 1962, the first experiment was done. At first, there was no problem in releasing the nuclear weapons. However, the Thor launcher engine malfunctioned, which caused the first test to fail. When it ascended to a height of between 9.1 and 10.7 kilometers, or 5.6 and 6.6 miles, scientists immediately released the rocket and its warhead in the sky for safety reasons. As a result, debris from the rocket and nuclear weapon fell into the launch site, Johnston Atoll, wherein effects were severe. The entire area was contaminated with radioactivity. After that, it was in 1962, on the 9th of July, that the second attempt to launch nuclear weapons into space happened. This second experiment was carried out by the same Pacific atoll, wherein a new Thor rocket and nuclear weapon were set to fly into space once more. The 1.44 megaton W-49 thermonuclear warhead soared to a height of 400 kilometers, or about 248.5 miles. And mind you, that's a really high altitude. So what do you think happened after this weapon was launched into space? Well, the explosion was nothing like what would occur if it were released on Earth. If it detonated on Earth, for example, a nuclear mushroom cloud would appear. But because it was launched at such a high height, there was almost no air. No radioactive clouds were formed. What happened during the explosion, on the other hand, was even more interesting than the special effects that we see in movies. The explosion caused a powerful electromagnetic pulse, since the nuclear weapon was detonated at a high altitude. A pulse of this size can disable electronic equipment, electrical appliances, and power lines in a short-term electromagnetic field. This means that 300 streetlights and other electronic devices that were located within a radius of around 1,500 kilometers or 932 miles from the explosion's epicenter were affected. Furthermore, an aurora-like glow was visible in the sky in the same vicinity for around 7 minutes as a result of the explosion. Aside from these, the spacecraft was also damaged, as well as 3 satellites were immediately disabled due to the intense electromagnetic pulse. The explosion also released charged particles which damaged the solar panels and electronics of 7 other satellites due to their high concentration. Overall, there is about 1/3 of the spacecraft in low orbit at the time of the explosion. All of these experiments taught us that we can't ignore the dangers that nuclear weapons might cause. We've seen via these studies that nuclear weapons can have very disastrous consequences when detonated on Earth or even in space. And what you've learned so far isn't even the worst case scenario. That's why, in 1963, a special treaty was created banning the testing of nuclear weapons on land, at sea, and in space. However, let us pretend that this treaty does not exist today. What do you think would happen if all the world's nuclear weapons were blasted into space at the same time? Every year, many countries create strong and destructive weapons, demonstrating that the global nuclear arsenal is constantly expanding. Despite this, the number of nuclear weapons in the world seems to be decreasing as shown in official statistics. For instance, there were only 13,865 warheads in the world at the start of 2019, compared to the 14,465 warheads in 2018. Moreover, only the United States, Russia, Great Britain, France, China, India, Pakistan, North Korea, and perhaps Israel make up the arsenal. 90 of these warheads are owned by Russia and the United States, while the remaining warheads were owned by the other countries I've mentioned. However, no one can tell the exact count of the nuclear weapons the planet has. This is because some nuclear weapons seem to be missing, while others are not being counted. Because of that, let's just use the number 15,000 as the total number of these warheads. Let's suppose I'm planning to launch all these nuclear warheads into space. What would happen now? Modern nuclear warheads that were launched from the strategic carriers have a range of power from 150 to 550 kilotons. But today, we wouldn't be estimating each one's specific power. Instead, we're going to pick an average. Let us imagine that every nuclear bomb we deployed into space generates a 350 kiloton TNT explosion. You might be wondering if this would create a grand light show in the night sky. Well, certainly. However, aside from this light show, we would also be impacted by a strong electromagnetic pulse. Do you recall our discussion about the Starfish Prime operation? Remember that in that operation, about a third of the satellites in orbit and a number of electrical equipment were destroyed by the 1.4 megaton warhead explosion. Furthermore, the blast contaminated the entire launch site due to radioactivity. I decided to calculate the amount of destruction that a 15,000 warhead detonation would cause using simple mathematics, and it turns out to be really bad. The explosion with a large number of warheads has the capacity of creating 5,250 megatons, and that's 3,750 times the strength of the warhead launched in Johnston atoll. Could you imagine how powerful that is? How about if the nuclear weapons did not reach a high altitude before being detonated? That means they could explode at 400 kilometers or 248 miles above the planet, which would cause the deactivation of every active satellite. Keep in mind that there are currently more than 2,000 satellites in orbit, and that the International Space Station, or ISS, is at this exact altitude, making it become affected as well. The ISS crew's chances of survival are slim to none. This is because of two reasons. The first one is that all of the onboard electronics would be damaged, so they couldn't make use of it. The second reason is that nothing could stop gamma radiation from spreading in an airless space. What do you think would happen to Earth's inhabitants because of this explosion? Electronics that can be found within a radius of 1,500 kilometers or about 932 miles from the epicenter of an explosion that would generate 1.4 megatons would be severely damaged. Moreover, a 5,250 megaton bomb has the capacity to destroy all equipment that lies within a radius of 5,625,000 kilometers or approximately 3,500,000 miles. Since our planet's radius is 6,371 kilometers, that only means the destruction zone would be 883 times greater than the mentioned operations. To put it simply, such a large-scale explosion would destroy all of the Earth's electronic equipment. And if you're thinking that this is the worst that may happen, well, it isn't, since there's always a danger that falling radioactive material will poison the land. You might be considering launching the warheads from a distance away from the Earth to lessen the effects of the explosion on the planet. However, all of our current spacecraft that are used for launching are currently intended for missions to low Earth orbit. Saturn V, which was part of the historic moon landing, is the only exception to this. However, creating such equipment identical to Saturn V is costly, and no one is likely to be able to achieve the necessary number of nuclear weapons I've used in this experiment. What do you think about this experiment? Given a chance, would you launch that amount of warheads into space? Tell us in the comments. If you enjoyed this video, give it a thumbs up, and don't forget to subscribe to the channel. Please click the bell icon so you'll be notified when new videos are posted. And as always, thanks for watching Ponder This.